These are your solutions to the geometry review sheet. Be sure that you're using a grading pen to fix anything that you missed and go ahead and star anything that you got correct. Starting with the first one, we're looking at converting scale measurements into actual measurements. We've actually done a lot with this year, so you can set up a proportion just like we've done before. So the scale factor right here will be the first fraction. So I can do 3 feet over 2 inches, and that's going to be the first half of my proportion. I'm going to convert each measure separately. Since 10 is smaller, I'm going to label that one the width, and I'll go ahead and find that one first. So 10 inches is going to match up with 2 inches, and then the variable W can go in the remaining spot. And then from here, you can either do cross products or you could do scale factor. Scale factor is going to be pretty easy because you can just multiply by 5 to get a width of 15 feet. All right, and then we'll do the exact same thing for the length. We're still using that same scale factor. And instead of putting in 10 inches, I'm going to put in 12.5 inches. So I'll go ahead and line up 12.5 inches in the denominator and length in the numerator. Now this time there isn't a nice whole number that we can multiply 2 by to get to 12.5, so I'm going to show this one with cross products. So we'll multiply 3 by 12.5, so 12.5 multiplied by 3 is going to be 37.5, and that will equal the other cross product, which was 2 times L. So 2L equals 37 and 5/10. And from here, we're going to divide both sides by 2. And when you work that out, you're going to get a length of 18 and 75 hundredths of a foot. And notice how both of our converted measurements are already in feet because our scale factor set it up to be that way. All right, in part B, we're going to use the dimensions from part A in order to approximate the area. It does tell us that we can round each of those to the nearest whole number since it is just an approximation. So we can multiply 15 feet by 19 feet, and that's going to give a total area of 285. And since we're talking about area, this is going to be feet squared. So exponent of 2 will show feet squared. All right, next one, we're going to do a construction. We need a triangle. 2 of the angles are going to be 35 and 55, so one of each, and one of the sides is going to be 4 inches. So we'll start with the ruler, and we're going to measure out a line segment that is exactly 4 inches long. Okay, once we've measured that, it's really helpful to label that. So side length is 4 inches. And then I won't need the ruler anymore. And now I'm going to pick one of the 2 endpoints of the line segment to line up the protractor. And from right here, we're going to follow it around going up, and we're going to measure until we get to 35 degrees. So that's going to be right there. And then we can just put a dot. And then when you move your protractor away, you'll use that straight edge on your protractor so that everything is nice straight lines, and it would look kind of like that. Since that was our 35-degree angle, we're going to put 35 degrees in the vertex, just like that. You always want to make sure angle measures go right inside of the vertex. Okay, now we're going to take our protractor, move it around to the opposite one, and this time we're going to measure 55 degrees. So since the line starts here, we're going to measure up like this until we get to 55, which would be right there. And then just like before, use the edge of your protractor to get a really straight line, just like that. And then we can label that one 55 degrees. Okay, and then do a quick check. 35 and 55 are both acute, so I want to make sure that those angles look like they are acute, which they do. If you want, you can clean up the ends if you want to make it look a little bit neater, but as long as you've got the angle measures you need, your triangle will get you full credit. All right, number 3. Two angles are supplementary. Make sure you know your vocab. Supplementary angles add up to 180 degrees. So angle A is 2x plus 40, and angle B is x plus 20. So we're going to take each of those expressions and we're going to add them together and set it equal to 180. So that would be a starting equation in order to solve for x. Okay, we'll now combine like terms. 2x plus x is 3x. 40 plus 20 is 60. And then we can just bring down equals 180. Now we've got a two-step equation. So subtract 60 from each side. So now we'll have 3x equals 120, and finally divide by 3 to get a value of x equals 40. So we can fill that in. Now for part B, we're going to go back to the original measures, and we're just going to substitute in 40. So we had 2x plus 40. So in place of x, plug in 40. 2 times 40 is 80, and 80 plus 40 is 120. Since these are angle measures, we're going to put a degree symbol on there, 120 degrees. Then for angle B, that one measured x plus 20, so we're going to plug in 40, and 40 plus 20 is 60 degrees. Okay, final step to make sure that your answer is reasonable. We said that these two numbers were supplementary, so that means they have to add up to 180 degrees. So when you test that, they do actually add up to 180. If they don't, you need to go back and check to see what you messed up. All right, next one, we have a picture copied onto a sheet of paper that's 12 by 14 inches. So I'm going to label 14 inches here and 12 inches here. Longer side has to be the bigger number. There's a 2-inch margin all around the picture. So using that information, this distance right here is 2 inches. This is 2 inches, and then same thing, 2 inches here and 2 inches here. So that's 2, not a 12. So that means if the entire distance is 12, that piece is 2, and that piece is 2, then we're trying to find the amount that's left over in between. So to do that, you're starting at 12, and you're taking away 2 for each of the margins. So 12 minus 4 is 8. That's the width, so we can put in 8 inches for the width. Okay, same thing along the length. We have the entire distance here is 14. This part is 2. This part is 2. So if we're looking for the length of the picture right there, then we're going to do 14 minus 2 minus 2. And 14 minus 4 is 10. So length of the picture is 10 inches. Be sure you're including units, super, super important for your geometry test to get full credit. Okay, next we've got some problems that have to do with the triangle inequality theorem. So let's quickly just remind ourselves what that theorem says. We're looking at the small and the medium side and how they compare to the large side. So if we add small plus medium side and it's bigger than the large side, then you do get a triangle. If you add the small plus the medium and it's either less than or equal to the large, then that will not form a triangle. So for part A, we've got side lengths. One side is 5, one side is 9, and then the other one is somewhere between 2 and 8. So it could be 3, it could be 7, it could be 7.5, anything in between 2 and 8. With that, because we don't know the length of the third side, we're actually going to get a variety of triangles, which shows that we're actually going to get more than one triangle. So for part A, you're going to have B. And we can kind of look at that also on number 2. If we add the two smaller sides and compare it to the third, 3 plus 3 is 6, and 6 is going to be larger than 3, so we will get a triangle, and there will just be one way to form that. Okay, and then finally, part C, we have side lengths of 4, 6, and 10. And when we add those, we get 10 equals 10, and since that does not form a triangle, we would circle part C. All right, next, identify the sketch where there is a rectangular pyramid. So right away cannot be the cube. So a rectangular pyramid where the cross section is cut parallel to the base. So this one right here, since it's touching the base, that's our cross section, since it's touching the base, that one's not parallel. This one is actually cut perpendicular. And then if we look at pyramid over here, notice how those two are parallel to each other. So the top one, that one is the cross section, and it's either going to be a square or a rectangle. It just says rectangular pyramid, so we don't know for sure that it's a square. So we'll say that the shape of the cross section is a rectangle. All right, number 7, we just need formulas for each of these. You will be responsible for having these formulas memorized. So area of a triangle is base times height divided by 2. So basically formula for a rectangle and then cut in half to get a triangle. Formula for area of a circle is going to be pi times radius squared. There are two formulas for circumference of a circle. The first one is pi times diameter, and the second one is 2 times pi times radius. Surface area for a rectangular prism, that's our one long one. We're going to have every combination of length, width, and height twice. So we can do 2 times length times width plus 2 times width times height plus 2 times height times length. And then finally on volume of a prism, that's going to be area of the base, capital B, multiplied by height of the prism. Be sure that you understand what capital B is. This is not just base times height. It is area of the base multiplied by height of the prism. Okay, number 8. This one was on your quiz, so really be sure you pay attention. We did this investigation in class. It says that to illustrate the relationship between circumference and area, we can take a circle, so this circle right here, and we can cut it apart and put it into this shape right here, which is kind of like a parallelogram. Any parallelogram is going to be base times height in order to find area, or in this case, they're using length times width. What we need to do is figure out why they are using pi times radius to represent this length of the rectangle right here. That's what you need to explain. So looking at the pieces that were cut apart, I'm going to trace the top part of this diagram. So notice that that's 4 segments based on how they cut it. So I'm going to trace 4 segments around the circle. 1, 2, 3, 4. Now we're trying to figure out what relationship that semicircle is compared to the whole circle. And that distance is actually going to be half of the distance all the way around. And we know that for a circle, distance around is called circumference. So we're looking at half of the circumference. So that's the first part of this, is that the length of the rectangle is pi times radius because pi times radius represents half of the circumference. You also need to include why that's half of the circumference. So remember, one of our circumference formulas was 2 times pi times radius. We're going to use that. So circumference is 2 times pi times radius, but I want half of that. So I'm going to take each side of the equation and just divide it by 2. Okay, so I have circumference divided by 2 equals 2 times pi times radius divided by 2. Now notice 2 divided by 2, that's going to be 1. So that part right there is just going to simplify out. So now we're going to be left with circumference divided by 2 equals pi times radius. So be sure you include the words along with the math that shows that half of the circumference is pi times radius. Okay, next we have a track. It's made up of 2 straight sections. So this is a straight and this is a straight, and 2 semicircles. So semicircle here and semicircle there. It says the radius of each semicircle is 25 meters. So we can go ahead and label 25 meters for that distance. It's also going to be 25 meters for that distance. The entire perimeter is 500 meters. So the straight plus the semicircle plus the straight plus the semicircle, all of that is 500 meters. We need to use that to find the length of one of the straight sections. So let's put a variable on each straight section. Those are the ones we're trying to find. Okay, to find the curved part, the circle part, I can do that semicircle and that semicircle. So in red, if I take these two and put them together, I'm just going to get one full circle. And we saw from before that circumference is 2 times pi times radius. So that'll give me the part in red, or all of the curved part of the track. So we'll go ahead and use our 4 steps. Circumference is 2 multiplied by 3.14 multiplied by the radius of 25. And then we can start working that out. 25 multiplied by 2 is 50. So we can do 50 multiplied by 3.14. And when you multiply those together, you're going to get 157. And units for that are in meters. So basically all the curved part is 157 meters. Now we just need to use that to find the straight section. So remember, the total perimeter was 500. The curved part is 157. So if we subtract that, we're going to get the straight sections. So we'll have our 2x's, and that equation will help us get just 1x. So 157 subtracted from 500 is going to give us 343, and x plus x is 2x. Now from here, divide each side by 2, and we'll get a final value of 171.5 equals x. And then again, this was in meters. So 171 and 5/10 of a meter. All right, next is a review of surface area and volume of prisms. So I've already put the formulas up there, and we can use those with our 4-step process to get each of the surface area and volumes. So before I start plugging everything into my formula, I'm going to label length, width, and height on the prism so that I know which numbers I'm using. So 3 and 6 represent the edges of the base. Since 3 is smaller, I'll label that the width, and then 6 will be the length. And since 2 is our vertical distance on the rectangular prism, that'll be the height. Okay, from here, we'll just substitute those in. So 2 times 6 times 3 plus 2 times 3 times 2 plus 2 times 2 times 6. Okay, order of operations, do all of the multiplying first. So this 2 times 6 times 3 is 36. 2 times 3 times 2 is 12. And 2 times 2 times 6 is 24. And then we can add all of those together to get 72. Super important that you pay attention to your units. This is area. And so we're going to have feet squared. Okay, on to volume. Capital B, remember that's area of the base. So area of the base is going to be this 3 by 6 rectangle. So that's my capital B. And then height is 2. So when we multiply all of those together, we're going to get 36. And then correct units will be feet cubed. So we'll use an exponent of 3 to represent our volume. Okay, next is the triangular prism. I'm going to break this down into each of the 5 faces. So on a triangular prism, we have 5 faces. The formula that we just used right here for surface area is only for rectangular prisms. It will not work for this one, no matter how hard you try. So let's start with our triangles. Okay, so there's 2 of those. There's a top one and there's a bottom one. So I'm just going to use this picture to represent each of the triangles. So surface area of that triangle, remember we're using base times height divided by 2 for a triangle. The right angle tells us our base and our height. So we're going to do 4 for the base, 3 for the height of the triangle. So we'll do 4 times 3 divided by 2, which is going to give us 6 for each of those 2 triangles. So first triangle is 6, and the second triangle is also 6. Okay, now we have 3 rectangles. So this rectangle right here is an 8 by 4. So that's going to give us a area of 32. Then we have this side rectangle, which is 3 wide and 8 tall. Just a little bit skinnier. 3 multiplied by 8 is 24. And then lastly, we've got this rectangle in the back, which was 5 by 8, a little bit wider than the others. And that's going to give us an area of 40. So now I have my 5 different areas, 6, 6, 32, 24, and 40. So when you add all of those numbers together, you're going to get a surface area of 108 feet squared. All right, and now volume. Area of the base, remember we're still doing base times height divided by 2 for our triangle. We already found area of the base was 6, so I can substitute a 6 for area of the base, and then height of the entire prism is going to be 8 feet. So multiplying those together, we're going to get a total of 48 feet cubed since we're talking about volume. All right, next couple, we're going to work backwards in order to find some missing measurements. So start with your formula. Volume is area of the base multiplied by height of the prism. It tells us the volume is 960 centimeters cubed. So I'm going to plug in 960 underneath volume. Base is going to be length times width for a rectangle, and then we're still multiplying by height of the prism. It tells us the width is 8, so I'm going to put an 8 under the width, and the height is 12, so 12 underneath the H. And then bring down everything else, and now we can solve for length. So 8 times 12 is 96, so we're going to have 96 times length equals 960, and then divide both sides by 96 to get 10 for the length. Now, since we're just talking about a length, this is going to be in centimeters. So 10 centimeters represents the length. Okay, similar idea for number 12. We're doing area of a circle. So start with formula. Area is pi multiplied by radius squared. And then we'll substitute in everything that we know. So area is 314. Pi is 3.14. And we don't know what the radius is yet, so we'll just leave it as radius squared. All right, I'm going to divide by the coefficient on both sides. So divide by 3.14. And the right-hand side, that's going to simplify down to 1. So we'll just get radius squared. And then 314 divided by 3.14 is 100. So now we need to figure out what number times itself will be 100. So the algebra steps for that would be to take the square root of both sides. So the square root of 100 is just going to be 10, since 10 times 10 is equal to 100. And then this is radius, this is just a distance, so it'll just be 10 meters for the radius. All right, next one. A circle has a circumference of 62.8 miles, and we're finding the radius. So start with circumference formula, which we know is 2 times pi times radius, and then substitute in everything that we know. So circumference is 62.8. 2 stays at 2. Pi can turn into 3.14, and radius. Okay, multiply 3.14 times 2 to get 6.28. Bring everything else down. And then divide by 6.28 on each side. So that actually works out pretty well. 62.8 divided by 6.28 is 10. And then units for that are going to be miles, which would be mi. It's a little bit different than meters, which is just m. All right, and finally, we're going to do a quick vocab review. Be sure you've got definitions and visuals for each of these. So adjacent angles are when you have two angles that are next to each other. They share a vertex and they share a common ray. Vertical angles are opposite of each other when you have two intersecting lines. So they will not share any of their rays, but they will have a common vertex. Complementary angles are when you have two angles that add up to 90 degrees. Supplementary angles will add up to 180 degrees. Diameter is the distance all the way across a circle, and that has to go through the center. And radius is half of your diameter. It's the distance from the center of the circle to the circumference. Circumference is distance all the way around a circle. It's your word for perimeter of a circle. Vertex is where you have two rays that meet in order to form an angle. An edge is a line where two faces meet on a three-dimensional figure. A face is a flat surface on a three-dimensional figure. And a prism is a three-dimensional figure with the bases parallel to each other. So that's going to be two bases that are parallel and congruent, and then all of the lateral faces, everything that goes around the sides, those are all going to be rectangles. All right, thank you for watching, and use this study guide to help you prepare for your upcoming test. Good luck.